This question is given in GATE 2008. Now see this question. Consider the symmetrical circuit shown below. This is the symmetrical circuit they have given. A triangular wave goes from minus 12 volts to plus 12 volts is applied to the inverting input of the op amp. They are saying that for this inverting input, they are applying minus 12 volts to plus 12 volts. Assume that the output of the op amp swings from plus 15 volts to minus 15 volts. Here this is the output. Here it is swinging from plus 15 to minus 15. The voltage at the non-inverting input switches between. Okay. They are asking that what is this voltage at this non-inverting input V plus. They are asking the what is the non-inverting inputs voltage that is ranging from. Okay. They have given four options. Option A minus 12 volts to plus 12 volts. Option B minus 7.5 volts to plus 7.5 volts. Option C minus 5 volts to plus 5 volts. And option D 0 to 5 volts. Now, by looking into this diagram, we have seen everything. Like here output swings from plus 15 to minus 15. Input ranges from minus 12 to plus 12. Okay. So there we can solve in two cases. Case one is Vi equal to minus 12 volts and V naught is equals to plus 15 volts. So V plus we need to get. This is the first case we need to see, where V plus is the non-inverting terminal of the op amp. Now apply KCL at V plus. Apply Kirchhoff's current law at V plus. At this point we are applying KCL. So this will be V plus minus of plus 15 volts. V plus minus of plus 15 by the resistor by 10 kilo ohm. Plus next V plus minus of minus 15 by 10 kilo ohm. V plus minus of minus 15 by 10 kilo ohm. Plus V plus minus of V naught by 10 kilo ohm. V plus minus of V naught by, and the V naught value is, we have got 15. So you can directly write 15 here, 15 volts, by the resistance value is 10 kilo ohm, corresponds to 0. So this is the important step. I applied a KCL at V plus such that the voltage difference between this point to this point by the resistance between that. Similarly, the voltage difference between this point to this point by the resistance between that. Similarly, the voltage between this point to this point divided by the resistance value. So if you take the LCM, denominator will be 10 kilo ohm, and after that 10 kilo ohm will be multiplied with 0. I am directly writing one step ahead. So V plus minus 15 plus V plus 15 plus V plus minus 15 is equals to 0. 0 because 10k into 0 will be 0. So here minus 15 plus 15 will cancel. V plus plus V plus plus V plus. 3V plus is equals to 15 and V plus is equals to 5 volts. This is how we got the first non-inverting voltage V plus at Va equal to minus 12 volts and V naught equal to plus 15 volts. We got V plus to be 5. Now we will see another case. This is case 2. Case 2 where we get Vi equal to plus 12 volts and V naught is equals to minus 15 volts. At this point we need to calculate what is the value of at non-inverting terminal. Now the same, for the same you need to apply again KCL. Here the input value is changed and the output voltage is changed. Okay. Now apply KCL at the same terminal. Apply KCL at non-inverting terminal. Non-inverting terminal means at V plus itself. At V plus itself. Okay. Now V plus minus. Now here we are taking we are taking as minus 15 volts. So it will be minus 15 volts by same 10 kilo resistance. Okay, plus V plus minus of, it will be 15 volts by 10 kilo ohm plus now V plus minus of minus 15 by 10 kilo ohm is equals to 0. Now if you take the LCM, denominator will be 10 kilo ohm. So when it go to the other side, it will be 0. So V plus 15 plus V plus minus 15 volts plus V plus 15 is equals to 0. So minus 15 plus 15 get cancelled. 3V plus is equals to minus 15 volts. V plus is equals to minus 5 volts. Okay. Here in this case of VI equal to plus 12 volts and V naught equal to minus 15. So we are getting the voltage at non-inverting terminal as minus 5 volts. So definitely the non-inverting terminal voltage will vary between minus 5 volts to plus 5 volts. Okay, this should be the answer. We'll check in the options. That is option C, minus 5 volts to plus 5 volts. This is the correct answer. How we have got the solution is, so by seeing into the diagram, we need to apply KCL. We need to apply KCL for getting the voltage at the non-inverting terminal. Okay, but they have given that VI varies from minus 12 to 12 and V naught varies from plus 15 to minus 15. So by taking these voltages, you need to apply at KCL. And how we apply KCL? The voltage difference across this by the resistance value, because current equal to V by R. You need to get voltage difference and you need to divide it the resistance value. Thereby you can add all the terminals such that you will get one equation. If you solve this equation, you will get the value. The other case also like the same which we have solved in the first case. Okay.